Hey everyone, happy Friday. We finally made it through another week. Let's talk tests. All your tests will be posted this weekend. I finally got most of them in. It is really hard to grade them online, which really sucks. But I want you to be able to kind of see what you're missing points on and stuff like that. So I've been messing with different ways to do it. There's not a real great way. So I want to try to leave you some feedback on them. But yeah, it's going to take a couple tries maybe. The retake, if you're interested in doing the retake, there's a Zoom meeting that will be next Monday at 6 o'clock and at 8 o'clock. There'll be two different ones. And you must meet me in that Zoom meeting and do some practice problems and stuff with me if you are interested in doing that. And then that's kind of your ticket, and I can send you your retake on Tuesday. And then you'd have till the end of the day Tuesday to get that into me. So that'll work pretty well for you guys because if you saw my post about map testing next week, I'm not going to send you anything on Monday or Tuesday. So just make sure you sign up for map testing on there. Today we're going to talk about negative exponents. So, let's say we're going to go through this little thing here. And if I start with 2 to the third, 2 squared. All right, we're just going to talk about 2's a little bit. Hopefully you can see that okay. See if I have a darker marker. So, if we look at this board up here, we're talking about 2 to different exponents. So 2 to the third, we know is, ooh, that one is terrible. All right, that's not a good one. Let me try a different one. All right, that one's better. All right, so let's say we had 2 to the third. We know that's just 2 times 2 times 2, which is 8. Correct? And 2 squared is 2 times 2, which is 4. And 2 to the first is just 1, 2, which is just 2. So then what do we think 2 to the 0 power is going to be? Well, I bet you would guess 0, and you would be wrong. Because if you look, there's this pattern thing going on. So if you look over here, every time we went down an exponent, what happened was we went in half. We went in half. And that's just because 2 is the base. But that's the same principle that's always going to happen with exponents. And so when we come down here to 2 to the 0 power, what we're going to find is that it's actually 1. Anything to the 0 power is going to be 1. So I think on your homework last night you had something with a 0 power. When you simplified it, they actually just cancel out and become 1. Anything to the 0 is 1, which is kind of cool. But that's going to lead us to this one. What about a negative exponent? Well, if we keep our pattern, half, 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 half of 1 is 1 half. And that's going to lead us into our conversation about negative exponents. Because you see, negative exponents are actually going to be fractions. All negative exponents are fractions. They're not negative numbers, which is what you probably think. They're all going to be a fraction. So if I gave you anything with a negative, also if you don't believe me because you think I'm crazy, put it in your calculator, and I bet you get a decimal, which is a fraction, right? So if I had something like 8 to the negative third, how do I simplify that? Because in math, there's this rule that you can't leave an answer with a negative exponent. So we're going to have to do something here. So what we're going to do is we're going to make it a fraction. And when we make it a fraction, it's going to make the exponent positive. So I'm just going to put a 1 on top of that. Put a 1 over the base. And that's going to make the exponent become positive. So 8 to the negative third is actually 1 over 8 to the third. That's how negative exponents work. Okay? Same thing with a variable. If I had y to the negative 12th, I'm going to make it a fraction, put 1 over y, and it would turn into a positive 12th power when I make it a fraction. So there's a lot of things that we need to do then. So yes, because negative exponents, let's talk about some things that we could see. Well, the first one is, what if I have a negative exponent? Let's say I had a to the 4th, b to the negative 7th, over c to the negative 5th. So, what if it's already a fraction, Mr. Odie, right? Because this one's already a fraction. What the negative's going to do, if it's already a fraction, is kind of, it's going to kind of flip it. So check this out. If it was 8 to the negative 2nd, we know that's 1 over 8 to the 2nd. Really, we know that 8 to the negative 2nd is really over 1, right? So everything's kind of a fraction when it starts. All we're going to do is move it to the other side, and when I move it, it became a positive exponent. So over here in our example, the a to the 4th, I don't have to do anything to that because it's already positive. But b to the negative 7th, that can't stay a negative exponent. So since it's on the top, we're going to move it to the bottom. And then what about c? C has a negative exponent, but it's on the bottom of the fraction. So if I want to make that one positive, where's it going to go? Up to the top, right? So those are going to kind of swap the place of where they're at. So this one's going to simplify a to the 4th, c to the 5th, over b to the 7th. And notice that when I move those, their exponents are all positive now. That's the whole goal. I can't leave it negative. I got to make it a positive exponent. That's what I did. Okay, cool. What about if I did some division rule? Let's say we have 44 x squared y to the 9th z to the 3rd over 11 x to the 5th y cubed z to the 12th. So this just looks like any other division rule problem that we did the other day, right? Yeah, you guys can see that okay, right? So what I'm going to do is same idea. If they have the same base, we know we can keep the base, subtract their exponents, but we need to make sure we go top down. So 2 minus 5 is x to the negative 3rd. Y's, keep the y. 9 minus 3 is y to the 6th. And z's, keep the z. 3 minus 12 would be negative 9. And then 44 and 11, they don't have the same base, so we're just going to divide those two because that's what the problem says, and that would give me a 4. But if you notice, after we do that, now I have negative exponents. So the last thing we're always going to check, I might have power to a power, I might have multiplication, I might have division. The last thing I'm going to do is check, does it have any negative exponents when I'm done? I don't want to fix them during the problem, I want to fix it at the very end. So in this case, yes, I have two things that have negative exponents. So I'm going to think of it as a fraction, and I need to move the stuff that has negatives. So the x is going to move to the bottom, the z is going to move to the bottom. The 4 and the y are fine because they both have positive exponents. Ooh, that always gets people too. I don't care if this 4 is a negative number, only if it has a negative exponent do I move it. That's a trick. Don't fall for that. So when I move these two to the bottom, I still have a 4 on top. I still have y to the 6th on top. And on the bottom, we're going to have x to the 3rd. And we're going to have z to the 9th. And that is my final answer there. Make sense? This is probably the trickiest of the rules. And it's not like I try to make it tricky. This is always the one that gets people messed up. I think it's just because you guys don't like fractions, and this is all about fractions. All right. I can combine this negative exponent thing with any of the things I've done so far. So for example, let's say we're multiplying 22, a to the fourth, b to the negative eighth, times negative 3, a to the sixth, b squared. So now I notice I'm going to use my multiplication rule, right? I have numbers with the same base. So I'm going to keep the base, and when I multiply, I'm going to add their exponents. That's a to the 10th. Same thing with the b's. Just keep the base, add their exponents. Negative 8 plus 2 is negative 6. And then 22 and negative 3, they don't have the same base, so we're just going to do whatever the problem says. In this case, that's multiply. So that'd be negative 66. But again, at the very end, I did my multiplication rule. Now I'm going to check. Do I have negative exponents? Yes, I do. So I'm going to have to fix something. So think of it all as a fraction. Negative 66 is fine because it has a 1 here. Not a negative 1, just a positive 1. A is also fine. However, B is not. So we're going to have to move B to the bottom of a fraction. So my final answer here is going to be negative 66, a to the 10th over b to the 6th power. Yeah. How long is this video? Oh, that's pretty good. All right, so that's how negative exponents work. Maybe I should do one power to a power, and then I'll be done. I don't want to make it too long. So let's say we had 5 f to the negative third, g to the 5th, h to the 9th, all, that's a weird 9, don't worry about that, all to the negative 8th or something like that, right? So if we have a power to a power, we need to make sure that exponent goes to everything on the outside, inside. So negative 8 multiplied by all the exponents we have. So that'd be 5 to the negative 8. F to the positive 24th. Careful when you multiply negatives. G to the negative 40th. And H to the negative 72nd. Then I check, do I have negative exponents? Yes, I do, right? So I need to move some stuff. 5 is a negative exponent, it's got to go. F's fine where it's at because it's positive. G has a negative exponent, we're going to move it. H has a negative exponent, we're going to move it. So F is the only thing left on top. Oh, let me scoot it over here so you can see. F is the only thing left on top. 5 to the 8th moves to the bottom, becomes positive. G to the 40th moves to the bottom, becomes positive. And H to the 72nd moves to the bottom and becomes positive. Just in case you're wondering, if we move the F to the bottom also, I would just put a 1 on top of that fraction. Because there's always a 1. If we don't see something, there's just a 1 there, right? So there'd be a 1 coefficient on the top. All right. That's all I got for you on a Friday. I hope you guys have a great day. Have a great weekend. And, yeah, check those test scores out when I get them. All right?